Bonjour. Hello. I'm Hilary, and I know we will have questions at the end, so please send them or send them on Twitter to hmason. Before we begin, I wanted to say hello and thank you. Also, I know it is getting late in the day, so if you have not had some of the excellent coffee just outside, go have some. It will help you stay awake and enjoy. And before I start talking about innovation and data and machine learning, I wanted to ask how many people in this room are engineers or data scientists? So how many? We have some nerds in the room. Very good. Okay, and how many people are here from business or strategy? Okay, some. I will find out later what the rest of you do. But it's good because I plan to talk today about not just data science, a little bit of that, but also about how you take a step further, how you actually think about creating new products through the data assets and the technology that you probably already have. And it's been fascinating and somewhat disappointing to see so many companies embrace data and then stop when they have a good dashboard, or to leave so many opportunities untouched and unexplored. And so I hope that in this talk, it'll help think about frameworks for developing, innovating, and building new things on data, and thinking a little bit about the creative technologies that we're just starting to see emerge. So things in machine intelligence, like software that writes language automatically, or even things like understanding the real world. So this is what I'm talking about today. Before I begin, though, I want to set the stage so we all know the world that we live in, and it is the year 2015. How many people here are familiar with Reddit? It's a social network. Okay, only a few. So the rest of you should not rush out to look at it because it's sort of like the armpit of social media. It is not Facebook, it's not Twitter, it's not about news and topics. It's a very free social network where people post all sorts of weird and bizarre and odd ideas they have. And on reddit.com, somebody asked this question. So the question is, if someone from the 1950s appeared today, what would be the most difficult thing to explain to them about life today? And here's the answer. I possess a device in my pocket that is capable of accessing the entirety of information known to man. I use it to look at pictures of cats and get in arguments with strangers. And I present this to you to show that technology is changing very quickly, but people stay the same, and human behavior stays the same. And here's another photo I'd like to use to talk about data, because this is President Obama when he was campaigning, and there's something remarkable in this photo, and that if you look closely, every single person is holding up a phone or a camera or a device of some kind. There's even someone in the front with a laptop, like this. Every single person here is creating data about this experience, and that data is going to the internet, and it becomes something that we can analyze and we can ask questions of. And I have a lot of experience looking, thank you. Someone just held up their laptop for those in the back. But thinking about how we take social data and how we ask questions of it, like what is the world paying attention to? Is it different by geography? All of this stuff. And data keeps growing. Every talk about data has a graph like this one. It goes up and to the right. It just keeps getting bigger. This one I like a lot because it goes down and to the right as well. It's like this ending tide of data. And there are reasons this is happening now in 2015, and really three. The first one being that we have cheap compute power. And I know I've heard the cloud mentioned at least a dozen times today already. But when you take something that was expensive and you make it cheap, you allow people to play. So data science is not new. It's something that has been done for years and years. It's been done in the financial industry. It's been done in insurance. It had a different name at that time. It's been under business analytics for some time. But it has gotten so cheap that it is possible to do ridiculous things and to play. And as one example, I used to work at a social media company, and we spent 8 hours on a compute cluster figuring out whether people clicked on more photos of cats or dogs on the internet. And the answer is dogs. Another example, this is from a wonderful Tumblr called We Put a Chip in It. Technology has gotten so cheap that somebody created an LED outfit for a dog. and they put it on Kickstarter, and this is now a real thing that exists. This is only possible because of the change in the underlying economics of LEDs, microprocessors, and systems. It means that people can be really free. They can play, they can experiment. And not all of these things will make great businesses. I'm a little skeptical of the future of LED dog costumes. But I do think that it opens up the ability for startups, for innovators to start to play with their data in a way that was just never possible before. The second reason is that we have algorithms. Now that we have data, and we've been working with this data for a long time, we have a good understanding of what we can actually do and learn with that data. And I'll get into that much more later on. This is a machine intelligence landscape put together by a venture capitalist named Siobhan Zillis. She's quite brilliant. This is showing all of the little bits of those algorithms that have gotten so well understood that they are now commodified in their own products or in their own services. This is not even counting the stuff that you can do, but you still need to do your own R&D and engineer yourself. This is growing rapidly. In the last year, we've seen an amazing explosion of these things. And the last thing is that we actually have data. It is becoming cheaper to keep the data than it is to throw it away. And that allows for a lot of cool opportunity. We have no Star Trek fans? Okay, I still like you. So out of all of this, these three things has led to the emergence of a profession called a data scientist. And data science is not a new thing. People have been practicing data science or elements of it before for a very long time. What is new about data science is the combination of skills and capabilities in one professional role that used to be separated among multiple professionals. And so when you think about what makes a great data scientist, there are a few different things they do. They can do mathematics and they can write software. Some of them are great engineers, some of them are not. That's okay. But you have to be good enough so when somebody hands you a database or gives you some keys and says, don't mess it up, you can get the data out, take the model you might have done on the whiteboard in math, and then write enough code to implement that model. They also communicate well, meaning that they are able to take what they learn from data and math and explain it in a way that somebody who is not a mathematician or a data scientist can understand it. And even more so, they have to understand the real problems people need to solve. So a great data scientist can listen to somebody with a business problem, can understand what they are actually trying to accomplish, can go away and do an analysis with some data and technology that they have convenient to them, that is something they can actually work with. They go back to that person and say, here is something I learned from the data that will help you make a better decision. So a great data scientist is not necessarily a PhD in statistics or in physics or in computer science. They're someone who has a lot of empathy, who can understand business, understand technology, and understand math well enough to put all of the pieces together in one person. And that's what's new about this role. And data scientists need to be supported inside the companies they work in. And those companies need to design for data, which is something new. And I want to talk a little bit about a few successful data products and then go through some process and ways of thinking about designing a company for data. I'll start with a story from New York City. So this is from the mayor's Office of Analytics under Mayor Bloomberg. He brought in a data science team, and he brought in some folks to manage them who were actually legal prosecutors, not data scientists themselves. And they started looking at allocation of city resources. And this was a project that I absolutely loved because it had a great effect with very simple technology and very simple math. So what they did was look at ambulance response times in health emergencies throughout New York. So it turns out that there are 300 fire department precincts in New York City, and each one has ambulances that roam around and ambulances that wait in the firehouse for a call. And they calculated the optimal point in each precinct for the ambulance to sit. And then they looked and saw where they actually sat. And it turns out they don't sit in the optimal point. So instead of telling them, here you, go sit over there, they went out and they asked. They said to the drivers, why are you sitting where you're sitting? And the answer is completely obvious if you're a human being, which is the driver said, there's a 24-hour coffee and bathroom here. There's not over there. And they said, that's cool. They found them a better place to sit closer to the optimal point, but also the resources they need. And they did another intervention where they looked at when someone calls 911 for an emergency, they looked at the order that the questions get asked in to optimize the handoff time to the correct agency. And they changed these two things based on very simple data, not even big data, small data, and they managed to reduce the ambulance response time in New York by 1 minute on average, which is saving lives. It's a big deal. So UPS is another famous user of data, and this totally blew my mind when I found out UPS trucks do not make left turns ever, because they calculated and figured out that it's actually faster to just go right. They also now do dynamic rerouting, so they combine maps with the destinations of every package in the truck, and they figure out the best path from A to B using data. This is pretty straightforward and easy to measure, but a great use of data. This one is a little bit more interesting to me. So this is a tweet from Monica Rogati, who's the VP of data at Jawbone. So Jawbone makes jam boxes, they're Bluetooth speakers, and they make wristbands that record your sleep. It's called the Jawbone Up. I'm not sure if anyone here has one or wants to be brave enough to say they do. No, okay, we got someone, cool. So this is a product you buy and you wear to sleep, and it gives you an app that tells you about your sleep patterns and your activity and your health. And yet when there was an earthquake in California, enough people were wearing these wristbands that her team of data scientists could locate the epicenter of the earthquake by people getting woken up from it. And this, I think, is super cool because it is a side effect of the data gathering system that they built. It's something they did not design for, but now have an opportunity to take advantage of. And here they did a lovely marketing piece, but there's more they might do. And they also just released a study on the impact of daylight savings time on wakefulness across the United States, extrapolating from their sample of US-based Jawbone Up wearers, which can actually quantify the lost sleep due to the time change, which is the first time we've had real data to discuss that very controversial policy around, all from a little wristband, and it's not even worn by that many people. So to conclude, I wanted to show you my favorite data product of all time. This is Google Maps with traffic. I don't know where we are. We're in Philly here. Can anyone guess what is the most remarkable thing about this data product? Okay, this is a trick question, or I wouldn't have asked. You have a guess? Is it coming from Waze? I believe it is, yes. So there's a remarkable amount of technology going on here. They're getting data from historical city data, municipal sources. They're getting data from people's phones, just tracking your passive activity as you run Google Maps in your car, on foot. They're taking data from Waze, so crowdsourced data. And yet, I find the most remarkable thing about this product is that it is boring. It is a data product with an immense amount of technology, and yet it fades into the background. And we are all trained to read these maps since the time we were children. Anyone can look at that and understand what they should do, what decision they should make based on that visualization. And yet it's something we take for granted. I think it's one of the most successful data products that we have seen so far. So if you want to think about creating products like this off of data that you may have or may want to have, spend a lot of time with different companies, big and small, thinking about these questions. And I want to discuss some of the problems and the opportunities for doing that. So where are they? The solution, it turns out, is half technology. And these are problems that people usually think are technology problems. And I cannot tell you how many times somebody says, OK, we have some data, we need a Hadoop, and then we have a data product. And it does not work that way. The other half of the problem is the people problem, the organizational leadership issues you have to face and the processes you have to implement in order to have the two work together intelligently. And the goals of a good process around data are to have data analysis that's repeatable. I also can't tell you how many times I see metrics from companies where 1 month doesn't line up with another month because a different person ran the analysis. They manage resources effectively. That means if you're bringing in scientists or data scientists, you don't have people who are going down a rabbit hole and coming back a year later and saying, oh, that was a hard problem. I'm sorry, I didn't solve it. But you're managing that process effectively. and you're prioritizing correctly. And one mode of failure we see often is that you have data scientists in an organization who don't have the perspective to properly prioritize the work they do. So they end up doing whatever comes first, or whoever they like best, they'll do that. But good process can really take something that would be otherwise very mediocre and boost it up. And process is usually a dirty word, but it's not. Process is like a programming language for companies. So it's a very simple way to think about keeping people aligned. And I want to share with you a very simple high-level process for data science that I've found very successful at many companies, and so have other folks. And I'll give you some references later as well. The very first step to successful data is to answer the question, what problem are we really solving? And if you are a data scientist, I'm sure you're familiar with the experience where someone comes in, sits down, and says, I need you to count active users from the last 2 weeks over some quality. And you might say, why am I doing that? And then maybe you'll get to the problem they really want to solve and what they really want to understand. But if you can explain that in plain language that anyone can understand, you'll be off to a good start. And this is harder than most people think. The second question is, what are the error metrics so that I know that I have a successful answer to the question I've just asked? And in machine learning, these are usually quantitative error metrics, so things like cross-validation. Sometimes in machine learning, you have to admit you do not have a quantitative error metric for success of an algorithm, and that is really embarrassing, but you have to admit it. And sometimes you're trying to solve a problem that just isn't the kind of problem that has a quantitative metric. And so it really helps to be able to say, my team will look at it and we'll decide if it is good or not. But we all admit in the beginning what a success looks like and where we're going. And finally, what are we going to do with it once we've done it? So make sure that the thing you work on has relevance. And I can't tell you how exciting it is to get a new data set and just go down that rabbit hole and think, oh, I could spend months just playing with this and learning whether people want to click on cats or dogs. But is that really useful? It should be useful. Next, how impactful is it? So if we do that thing and we succeed at it, will it actually change something that matters? Is it impactful to the business or the product? Will it actually be a tweak to something that no one cares about? Or is it something that could actually really change our direction or our success? And that's really important because there are always more questions than you have time to answer. And finally, this is one I like to ask. And I like to ask it for 2 reasons, but most companies are not interested in asking this question. What is the most evil thing that can be done with this data? And I ask this question for 2 reasons. The first one is that we are starting to see a lot of discussion around the ethics of algorithms and whether you use a model and that model may encode some bias that existed in the data that fed into the model, and whether the model is therefore perpetuating some kind of effect that you do not want to perpetuate. You should ask that question for that reason. The other reason is that I tend to work with people who are lawful good. They went to school, they got very good grades, they did all of their homework. They tend to constrain their thinking into the boundaries of their success. And so if you ask them, instead of imagining you're you, successful data scientist, but you think instead, I'm an evil villain sitting on a mountain with a little cat, and we're trying to do something terrible, what would I do with my data and my technology? And out of that, you get really good ideas. So you get people to stop thinking inside their little well-behaved job box, but they start thinking really creatively. And those things may not be things you actually want to do, but if you sort of evolve them a little bit, you will get some really good creative, innovative thinking out of this question. So I'd encourage you to try it if you're brave. And the final question people ask often is really, where do I begin? So where do I start? I have data, maybe, what do we do? And the first question to ask there is, what data do you have? So this is something we call a data census. So you come into a company, they say, we want to start building new products. We have a business, maybe we have some products. Usually I will ask, what data do you have? And we'll make a list. And you can do this in a few different ways. You can just ask people. You can also do it from an infrastructure survey. So just look at all of the database servers that exist in their system and say, what's on here, what's on there? And the last thing you can do is look at it from a product perspective. So have some unaffiliated observer sit down with the product and write down everything they think should be there. If you do all of these things, you will eventually triangulate onto what is there. And the next question is, what data should we have? Because people always find a gap. Even if you're working at a tiny little startup that is 3 months old, you will have forgotten to log something useful, and you will probably be logging a lot of not useful stuff. So what do we have? What should we have? And then what assumptions do I make that I can now experimentally verify? And we all make assumptions. It's how we actually manage to operate in a world where we take a lot of information and distill it down. But I want to share a story quickly just to demonstrate why this is important. So I used to work at this social media company called Bitly. I was the chief scientist there for 4 years. And one day, this guy came into our office. He was the CMO of a major breakfast sausage brand. So they sold frozen breakfast sausage across the United States. And he said, I'm here because I want you to tell me what my clients do when they're not reading about breakfast sausage. And my customers are mothers who live in the Midwest of the United States. And I said, okay, how do you know that? And his reply was, well, this is my business. Of course I know that. So I said, this is an assumption we can validate. And I went to look at the data, and it turns out that he was correct. He had many mother-like types in the Midwest. We didn't know if they were actually mothers, but they were reading content very similar to what you might imagine mothers would read, and they were geographically in the Midwest. But he had missed out on a gang of biker types, people reading about motorcycles and mud wrestling and things in Texas. It was very different from what the Midwest crowd was reading. And he had missed out on another group of health people in the Pacific Northwest who really liked his product because it didn't have a food additive that a competing product had. And so these are the sorts of ways that you don't use data to replace intuition. I think a lot of people are afraid of that, but it's not the way it works at all. You use data to enhance your understanding of the world and to see the little things that enhance your intuition and your understanding of your own business. And so take those assumptions that you make, validate them with data, and when you find something new, use it. So he was able to actually launch some new marketing off of that information that he would not have been able to do before because he didn't even know those people cared at all or existed or were customers. And that's really just that's a very simple example. So within organizations, we often see a problem where only a few people have the data, and then those people get overwhelmed, and they either get very sad or they turn into jerks. It's a good word. And so you want to take the data and push it out as far as possible within an organization so that everybody has the power to ask the simple questions, and then you can save the data scientists for the complex questions. And have metrics meetings, that is, don't just leave it to one person to interpret the data because they will make up whatever they want to see in it. And I can tell you as a data scientist, I can make your data say whatever I want it to say. So you need to have multiple people who agree ahead of time on what action they will take based on data and who sit together to look at the data. And we all think metrics meetings should look like this. Like they should be shiny and have lots of great looking professionals with graphs. More often they look like this. They're really messy. You're at the beginning, you have more questions than you have answers. But it's a very valuable activity to spend time with your colleagues together looking at the data before you make decisions. And also not to follow data blindly, because that will inevitably lead you to do something so stupid people will not believe it and they will write an article about it. This is just one of many drivers who actually drove into, in this case, this was somebody who drove off a cliff because their GPS told them to, but people have driven into lakes. They've driven off of legal roads all the time because they trust their technology over their brains. And I'm sad to tell you that we are not at a point with our technology that we can trust it over our brains. And finally, a lot of people ask about tools. So what software do I need? And the answer, of course, is that you need smart people, and they will bring the tools they need. Good people is much more important than good tools. That said, there are a lot of exciting new tools emerging. Now, a lot of this stuff is written up in a free ebook I wrote with DJ Patil, who's the chief data scientist for the White House now. So if you want to download it, you can go ahead. It's free, so it's not even a book ad, but do tell us what you think, because we had a lot of fun writing it down. He had a very similar job to mine at another venture capital firm where we were both floating around talking to companies, big and small, about their data practices, and really could not find a good place where this was all written down. So let's talk, that was all about people and process and organizations. I want to talk about technology, and I saved it for last because that's what I'm really excited about. So I'm a computer scientist. I work in machine learning and what I call very applied R&D in machine intelligence. The work we do now is really around identifying emerging algorithms, so sort of things that are becoming possible but are not yet commodified or useful, and making them useful to people. And what's happening on the technology side right now is really exciting. It is changing very quickly, as in, week to week, the capabilities are evolving. And we're starting to figure out how to integrate it into our development process. So if you're an engineer or a software engineer, you probably build systems that look sort of like this column. So you have infrastructure, you have perhaps some data store, you have an API layer, an application layer. We really are very good at building these sorts of products. So we know agile development practices, how to spec things out correctly. Now we need to figure out how to take the data science and R&D and fit it into that process in a way that reduces friction. And this is something that's still evolving. But technology makes it easy. Now, to talk about the things we're good at, we are technically very good at analytics, that is, understanding human behavior through software applications. We are very good at building dashboard visualizations. There are many products in the market that solve that problem. We are great at anomaly detection, cohort analysis, those sorts of common problems that pretty much everyone who works with data generated by human beings has to address. We are mediocre at recommendations, that is, showing users other things they might want to engage with based on their behavior. Search algorithms, finding the right piece of content. Real-time analytics, that's something where we're seeing a lot of investment in infrastructure, but it has yet to really become as commoditized as batch analytics. And currently, we are starting to see progress in natural language, and I left the last word off because you might say natural language processing or natural language understanding. There's a whole spectrum of things that are really exciting happening there. Real-time decision-making, so not just real-time monitoring, but actually creating models that respond in real time. Real-time itself is a term that can range from nanoseconds to, well, days if you're an economist, nanoseconds if you're in quantitative finance. Again, with human data, we tend to think of real-time on the order of seconds or the time it takes for a human to interact with the application. Rich media analysis, so things like deep learning giving us insight into image, audio, video data, where before we sort of accepted as a dirty secret of data science that you just had to ignore the rich media data. Now we can actually analyze it. And these are things that are sort of popping up right now. And the things that are possible are moving from purely rules-based to things that we might have called creative. And there's a saying right now in the field that AI is anything a computer can't do today, meaning that at one time AI was a computer can't play chess. Now AI might be a computer can't drive a car, except it sort of can. And now a computer can't understand emotion. Well, maybe we're getting there as well. So one example of an algorithm that started emerging that we're seeing a lot of exciting work in is natural language generation. That is taking highly structured data and producing narrative. Our work and most of the research work, unfortunately, is focused in English, though there is one very successful French company in this market. It's called USI. But that's a big opportunity. So we looked at natural language generation at Fast Forward Labs, and part of what we do is to write down how it works, who's doing it, do a whole survey of the technology in the market. We also built something. We built a real estate advertisement generator. So this is focused on New York, and I don't know how many of you have been there, but we have small apartments, and we like them a lot. And in this example, you say, I have a house with 2 bedrooms, 1 bathroom in this location. Here are the amenities or the things that come with the property, and it writes the description for you. We learned a lot of things. So this is based off of a corpus of a couple 100,000 real estate listings. We learned things like if somebody says the property is cozy or small, it is 400 square feet smaller than the average for that location. If they say it is large or grand or spacious, it is at the average or slightly below. So if real estate agents ever talk about size, it's small. And perhaps what we see here is an unconscious bias of real estate agents encoded into the language they use, which is then detected and mimicked by this software. But this is just one example application. This is actually catching on more to write articles about things that are very statistically regular. So sports reporting, it's being used for financial news reporting. I think some of the biggest opportunities, though, have not even been discussed yet. There are things that are able to take very large amounts of structured data. So say a customer file that might be 20 pages long, and compress it into 2 sentences when somebody walks into a business and says, Hilary has been a customer for 8 years with these products. Here's what you should sell her. So there's many opportunities in this technology, and it's still very early in its development. And there are many more things like this that are starting to emerge. We're starting to see much more data from the real world. A lot of people call this the Internet of Things, but I personally really don't like that name because it's really creepy. And it also focuses very much on the things and not on the flow of information and intelligence in those things. But it's become very cheap to collect data from the real world. And so if you think of data science as processing the data, you can think of Internet of Things as generating more data from our physical space. And I believe we will see, like we saw with human behavior data, a lot of work going into analyzing the same kinds of data, so we became very good at it. You'll see the same thing happen to our local environmental data, whether it's wearables, items in your space, things you build yourself. It's becoming much cheaper. And the tools are evolving. So since I work with a venture capitalist, I hear a lot of pitches for new companies and new startups. And the 2 I hear the most are data science development environment in the cloud, so all the tools data scientists need in a box, or we're going to replace data scientists with AI, and you don't need to hire them anymore because they're expensive and a pain. I don't think either of these things are really successful models, but the tools are evolving quickly, particularly the open source tools. So this is just a screenshot of something called IPython. And they're evolving because as these algorithms become more well understood, they become commoditized and standard, and the implementations end up in tools. And personally, I think the most interesting work here is happening in open source because it doesn't constrain you into one environment. So a lot of the commercial tools require you to use it for everything. In open source, you can pick and choose the pieces that you want. And data scientists tend to use this stuff. Right. We're also seeing a lot of really interesting work happening in real time, again in quotes because it has that ambiguous definition, could be nanoseconds, seconds, days. But the ability to build models that react very quickly to change the way you work with algorithms. So in our current model, we have, in Hadoop, we use the MapReduce model where you sort of go through all of the data, you take your conclusions from those separate pieces of data and combine them together, and then you return results, which means that even a very simple question has a large amount of overhead in terms of time and compute expense. And we're starting to change the way we think about those algorithms to think about them in a real-time sense, meaning you have a stream of data, you look at each item in that stream one time, and you update an online mathematical representation of what you want to calculate from that stream. And that's a topic I think is super exciting. If you want to get into it, look for probabilistic models, because it lets us do a lot of really fun real-time visualizations. And so finally, this is a really exciting moment to be integrating analysis, research and development, engineering, product, and business strategy all into one sort of overall strategy. And we are learning still a lot about how to do this well, but have made a ton of progress. And I do believe the biggest opportunities might be surprising. So a lot of people think that innovation comes from startups. But when you spend a lot of time with startups, you really learn that they are not innovating necessarily. They are taking commodity technology and creating maybe a new product on 3 different APIs. They're not inventing new technology, and they certainly don't have data. And the people who have data are people who work at large companies that have been running businesses and products for many years, that have been collecting a lot of data, perhaps even as a side effect of the business they were running, and even today are just starting to think about what they might be able to build. And when you work with large companies, we see adoption of data in two phases. The first one is the adoption of data to solve a problem you already pay money to solve. And that is really easy to do because you can point to a technology and point to the ROI and say, if we do this, we make this many dollars because we don't spend this many dollars or euros or whatever. And that's very easy. But what's really challenging is saying, OK, we have this data, we have this technology, now we can build a product that has never existed in the market before. We don't know what the ROI will be, and it might fail, but it also might be much more impactful than that thing where we already have a constrained upside. And so I really try to encourage people to take that step beyond what they already know is going to be a win into those things that are a little bit experimental, and to have a good process of experimentation so that you can actually build something new and innovative inside of a large organization. We're starting to see that happen. I also like to ask that question, what kind of world does our new technology enable? And it is a great time to be asking this question around data analytics and artificial intelligence. I'm not someone who thinks AI is dangerous. In fact, as somebody who builds AI, I can tell you it is so stupid that it is only dangerous as a side effect of its stupidity, not because it's malicious or coming after us. There is still a big difference between solving any kind of generalized AI problem and the very domain-specific systems we can build today. That said, when we build these systems and put them in place, we need to think about the impact that they have on the people who use them. And with the scale that a lot of these products are able to achieve, potentially even billions of people using one product, you actually do influence global human behavior. And so we need to think about this. And when you talk to data scientists privately, this is the topic that everyone is thinking about right now. What are the ethics of my data storage, my data governance policies? How do I do this well? That's what gets talked about behind closed doors, because nobody wants to do it in the open. And I really do think we are at the very beginning of the potential with data and with data technology, and it will continue to be a really exciting area to work in for at least the next 10 or 20 years. And finally, I want to say that I do think data gives us superpowers in the sense that it gives us, as unaugmented human beings, the ability to perceive the world in a way that we just could not do otherwise. I think the technology we carry with us every day has the potential to make our lives richer and a lot more interesting. And so with that, I will end. Thank you very much. And if you have questions, send them through the app or to me on Twitter or email, and please stay in touch. So
Merci.
Thank you.
Merci, Hilary.